So I'm going to go on and move on to question number 8, which is going to be the last question for this chapter. So in figure 4, a bird changes direction in 3.8 seconds while flying from point 1 to point 2. Determine the bird's average acceleration. So we'll assume the velocity at point 2 is its final velocity and velocity at point 1 is its initial velocity. To do this question, it's going to be a little bit more difficult because we're going to have to again convert to components because this is north and this is south. And it'll be easier if we convert to components and then do the calculations. So I've already gone ahead and drawn a diagram. This is V2 and this is V1. So to find the change in Vx, we're going to go ahead and convert these to components and then find the change, because as you already know, acceleration is the change in velocity over change in time, which is Vf minus V1 Vi over time. So to find the x component, I'm gonna do Vfx minus Vix. So if we assume V2 is Vfx and V1 is V1x, we can find x component of the change in velocity. So that's going to be V2x minus V1x, 8.5 cos 30, since cos is adjacent, and minus 6.4 cos 30. They're both going east, so you can just subtract them east and east, and you end up getting 1.818 meters east. Now for the y direction, or the y components, it'll be V2y minus V1y, 8.5 sine 30 north, and here you have to do a little bit of a conversion, since it's north for the V2 but then V1 is south. Since we want to make them both in the same direction, we're going to make V1's y component into the north direction by putting a negative in front of the coefficient. So instead of it being 6.4 sine 30, it's going to be negative 6.4 sine 30 north, which is the same as 6.4 sine 30 south. We just put a negative sign to make both of these in the same direction, so it's easier for calculations. So 8.5 sine 30 north minus 6.4 sine 30 north equals 7.45 north meters, or 7.45 meters north. So basically it's just getting these added because minus and minus becomes a plus. So I've gone ahead and drawn a diagram, change in velocity, in x component velocity, y component velocity. So to find a change in velocity, I used the Pythagorean theorem and did root of Vy squared plus Vx squared and ended up getting 7.668 meters per second. But remember, this is on an angle, so it can't just be 7.668 meters per second. It has to be on an angle. So to find the angle, I just did tan inverse 7.45 divided by 1.818, since Vy is 7.45 and Vx is 1.818, and since tangent is opposite over adjacent, find tan inverse, and I found 76 degrees. And now the question was originally asking you to find the average acceleration. Now that you have the velocity, or the change in velocity, that's going to be average acceleration is going to be the change in velocity over change in time. Plug in those values. Change in time was 3.6 seconds. You already have your velocity that you calculated, and you end up getting 2.01 meters per second squared east, 76 degrees north. Hopefully this video helped you out. If you have any questions, just let me know, and yeah, give this video a thumbs up, and I'll see you guys in this next video.